Today we're talking about simplifying radicals. So an expression with radicals is in simplest form if the following are true. 1, you can't have any perfect squares left inside of the radicand. So in this example we see that they have changed square root of 8 into the square root of 4 times 2. And the square root of 4 is equal to 2. But there's also the extra 2 that's left over. And we see that that stays on the inside. The other way that we could model the same problem is to make a factor tree of 8. So 8 is 4 times 2, and 4 is 2 times 2. And since square roots and squares are opposite functions, we can take the 2 squared, the 2 can go out in the front, and the extra 2 that's hanging around gets stuck on the inside. So the first thing you always have to look for is, can we square root anything else that's left inside of the radical? The second thing they have to look for is that there's no fractions in a radicand. In other words, like if I have square root of 5/16, I can't leave it as square root of 5/16. I need to put the square root on both the top of the fraction and the bottom of the fraction. And then when I do that, I see that the square root of 16 is 4, and the square root of 5 does not come out to be a whole number. I also cannot leave radicals in the denominator of a fraction. So in this particular case, I would not be able to leave this as square root of 4. I would need make that square root of 4 into a 2. There's also the possibility where you may not have a nice easy square root in the denominator, such as square root of 4, which I can make into a 2. So this example here, I've got a square root of 3 in the denominator. And in cases like this, we need to do something called rationalizing. There's a little a in the middle. Rationalizing. And in order to rationalize, you have to multiply the top and the bottom by the square root of 3. So after you multiply the top and the bottom by square root of 3, this bottom would make square root of 9. And the square root of 9 is 3. So it gets rid of the radical in the denominator. Now let's look at these examples. So all 3 of these examples have to be factor treed to see what could come out of the square root. So for example, 24 is 4 times 6. 4 is 2 times 2. 6 is 3 times 2. So again, when you go to simplify, you can see that there are 2 2's. That means that the 2 can come out of the radical. And the 3 and the 2 are singles. They only have 1 of each. So those are going to stay inside the radical, and you multiply them back together. Okay, why don't you put the video on pause and see if you can try the next 2. Okay, so in the first example, we can see that we have the square root of 72, which is 9 times 8. 9 is 3 times 3. 8 is made up of 2 times 2 times 2. For every 2 things that you have going on in the problem, you can take 1 out. So 3 comes out, 2 comes out, that means that 6 comes out. And the extra 2 that you have is stuck. In the last example, the 3 in the front is going to get multiplied to your final answer, so you don't worry about that 3 that's in the front. You factor tree your 200. 200 is 20 times 10. I can get it down to 2 times 10. And then I can see I have 2 10s there, so the 10 can come out of the radical. I don't have to take the 10 and make it into smaller prime numbers, because as soon as I see 2 of something, I know it comes out of the radical. And then I would take the 10, put it in front with the 3, and multiply the 10 times the 3 together. Okay, in the next section, you're going to take care of your square roots. So the first thing I always look for is if the fraction is completely under the square root, I look to see if I can reduce the fraction. But I can't reduce 3/4. So I'm going to go ahead and I'm going to put the square root on both the top of the fraction and on the bottom of the fraction. So doing that puts radical 3 over radical 4. I don't know what radical 3 is. It's some sort of a decimal, but the square root of 4 is 2. In part B, the square root has just on the top of the fraction, so you cannot cancel the 20 and the 4 because one has a square root and one does not. So I'm going to go ahead and I'm going to take square root of 20. I'm going to do a factor tree. I see 2 2's. That means the 2 gets to come out of the radical and the 5 is left on the inside. Because it is extra, it doesn't have a partner. And lastly, I can simplify the 2 and the 4 by canceling. And that would then be my final answer. The last one, we're really happy because the whole fraction is under the square root, and I can see that the top of this can be divided by 2. The bottom can also be divided by 2. So this radical can be simplified into square root of 16 over 25. And then the square root can go on both the top and the bottom. Square root of 16 is 4. Square root of 25 is 5. Why don't you now take a moment to put this video on pause and see if you can get these 6 answers. These are the answers to the 6 problems. The next thing we need to worry about is rationalizing denominators. So again, when you see a whole fraction underneath a square root, you want to see if first you can reduce the fraction, but 5/3 cannot be reduced. So you would go ahead and put the square root on both the top and the bottom of the fraction. Because the square root of 3 cannot be simplified, I need to rationalize that denominator. So I multiply the numerator and the denominator by square root of 3. What happens then is on top you get a square root of 15. On the bottom you would get square root of 9. And the square root of 9 is 3. And the square root on the bottom disappears. Part B, I can see there's a square root of 7 on the bottom. So I'm going to go ahead and rationalize by multiplying by square root of 7 over square root of 7. On the top I get 3 square roots of 7. On the bottom I get a square root of 49. And square root of 49 is 7. So again, it gets the square root out of the denominator. Whereas when you're looking at part C, there is no square root in the denominator, so the denominator is fine. So in this case, the only thing you have to worry about is, can 45 be simplified? And sure enough, it is made out of 2 3's. So on the top, I would have 3 square root of 5. On the bottom, there's the original 3, and the 3's can cancel. The next one, I'm going to reduce the square root of 3 and the square root of 12 by dividing by square root of 3 because they're both divisible. So then I have a 4 on top. On the bottom, I have a square root of 4. Square root of 4 is 2. 4 divided by 2 is 2. So again, every time you see a you should always make sure you can't reduce. And actually, this one can be reduced. The top can be divided by 25. The bottom can be divided by 25. So on the top, you get square root of 7. On the bottom, you get square root of 2. And now you can go ahead and rationalize. So I would multiply the top and the bottom by square root of 2. And I come up with square root of 14 over square root of 4. And square root of 4 can be reduced to 2. Let's look at multiplying radicals. The deal with multiplying radicals is that the insides of radicals can be multiplied together, as well as the outsides can be multiplied together. So for example, square root of 3 times square root of 7 would be the square root of 21. Cube root of 4 times cube root of 4 would be the cube root of 16. Now you should see if you can simplify the cube root of 16. So 16 is 4 times 4. Each of the 4s is a 2 times 2. And I notice that I do have 3 2's. So a cube root and a cube are opposite functions. Since there's 3 2's, it means that the 2 can come out. And the only thing left inside of the cube root is this extra 2. On the next one, the outsides would get multiplied together. The insides would get multiplied together. Square root of 16 is 4. 15 times 4 is 60. Why don't you pause the video and see if you can try the last 3 examples. Okay, take a look and see if you got those answers correct. The last thing that we need to look at today is distributing of radicals. So for example, you can see that here, this square root of 3 needs to be distributed. That would make the square root of 36 minus the square root of 72. 36 square rooted is 6. 72 you would need to factor tree. And I would be able to see that a 6 would come out. And still stuck on the inside is just the 2. That would be your final answer. And part B, you could distribute each of these things by square root of 3. Square root of 18 divided by square root of 3 is square root of 6. Square root of 6 divided by square root of 3 is square root of 2. And those cannot be combined because they are not the same type of radical. Okay, now you can go and check out the homework and try to get that done for the next class.